Now we have got our focus question, we have identified our variables. Next we're going to have a look with the students at the materials that we're going to be using and our procedure. So for this investigation we are using alfoil baking trays. Now I have picked these up from Woolworths. I've got 4 for $4 and we've got 4 of those. We're going to be setting those one inside the other. Next I have got a couple of styrofoam cups. I will need a pair of scissors for what I'm going to be doing, and I've also got some sand. Now this is just stuff that I got out of one of the school long jump pits. That's going to work perfectly well. What we are going to do is we are going to put a layer of sand into 2 of these trays, now of equal depth, because that is one of the variables that we'll need to control, and the same type of material, no vegetation, and then we're going to run water over the slope that we create and see how much erosion is going to happen. Now credit to Mr. Sony at Waterford, because he actually introduced me to this experiment. And the good thing about it is, with the alfoil baking trays, you can see I can put one tray and just angle it slightly like that, and then I've got my other tray, and to increase the angle of the slope I just need to pull it back further, and so water is going to run across those and then collect down the bottom here. Now, so to get the water to flow through, of course, we're going to need to make some holes. So I'm going to step you through that part of the procedure right now. So you've got your 2 baking trays here. Now we want the holes to be in about the same place and of the same size. So with a pair of scissors, and I usually do this part myself, just so that you can't have any accidents with the students, just pushing that pair of scissors carefully through the baking tray. Oh, there we go. And give it a little bit of a twist, right, so that you get a hole. And then we're pushing a few of those through, like that, until you've got 4 of those holes lined up across the bottom there. So actually what I'm going to do then is I'm going to make these my soil trays. So we'll have these as my bottom trays, and they'll go one inside the other like that. Now with my styrofoam cups, I'm actually using one of the cups to get the water to flow through. So what I've already done here is I've got my pair of scissors and I've made holes in the cups, and because how much water flows across and how quickly it flows across is a variable, you'd need to be making the same number of holes for each group. So if you're getting the students to do this, you'd be saying to them, we're going to be making this number of holes and about this big. And the other cup remains intact. And then of course, you've got your soil. Now what we're going to do is we're actually going to do the investigation. So I've got things underway here. I've put a layer of sand down in each of my soil pans, and because I had the pans one inside the other when I stuck the scissors through, I've been able to keep the height of the holes the same. So I've pressed this sand down here, so I'm going to need to do the same on this side, because that's another variable we're controlling. And if kids were to say, hey, Mr. Crawford, you know, you didn't say anything about how hard the soil was pressed down, I'd be saying things like, yep, you're right, we need to quickly add that to our variables grid. Make sure that everybody's doing the same thing. So get that last little bit of sand in there to even it up. Alright. So now what we're going to do is we're going to run water over both of those slopes. So obviously the holes are going to be on the downward side. So we'll put the first pan aside. Sorry, the second pan. Alright, so this is how I'm going to start. So I've got my pan and I'm just going to drag it back So about this much. Now, if your kids are keen and you've got protractors and you want to work out the angle of the slope, that's fine. But generally speaking, for this investigation, we can just eyeball it. So the further back I pull the pan, the steeper the slope becomes. So we've got this here. Now, remember I've got my 2 cups. I've got 1 cup with a hole and I've got 1 cup intact. So for this investigation, I get the kids to run 2 cups of water over the surface. So to do that, I'm going to fill up one of the cups, and then I'm going to pour into the other cup, and it's going to go through the holes, and it's going to rain down onto the sand. But there are variables that we need to control, remember. So the height of the cup is going to affect the force of the water striking it. If we have it here, the water is not going to be travelling as fast as if we have it up here. So we're going to have to keep the cups at a uniform height. Kids might want to use a ruler to do that. Also, we need to make sure that the water is falling in the same place. If we have the cup here for the first trial and here for the second trial, that's going to make a difference. Remember, controlling those variables. So I've got my cup about here. I'm just going to call that a fist height. Alright, like that. And pouring the water in, and the cup that I'm pouring into never fills up because it's got those holes in it. Alright, so that's the first lot. Then refill my cup without the holes. Go by fist height again, same position. I've even managed to keep the holes in the same arrangement. Let that drain. Okay. And then what the students can see is erosion is occurring. So we've actually got some interesting stuff happening here. We've got water travelling in 2 different channels. So we've got a slightly higher area here. The students can see that this is where the water hit, and so it's got a deeper gouge in the ground there. And the great thing about this investigation, doing it this way, credit to Mr. Sony, is that in that bottom pan we can actually measure how much soil has been washed down. You know, you can drain the water out and then you can measure a quantity of soil that has been washed down. Alright, so that's our first trial. For this next part, we're going to increase the angle of the slope. Now, I can't hold this pan back and pour at the same time, so I've got Deb here helping me out. Say hello, Deb. Hi. Okay, so what we've got is, we've got the slope at a different angle. Everything else we're keeping the same. So, once again, pouring the water into the cup and making sure that's a fist height. Again, same position above the pan. Alright, so that water's flowing through there, and one more cup. Fist height. Here we go. Okay. And so what we've got now is our second trial. Thanks, Deb. And then we can put these side by side and have a look at them. Now this is where the students are now writing down their results. So for an investigation like this, I would say that drawing a diagram of the 2 different trials is probably an excellent way to go. And getting the students to observe, use that word, observe the differences. Now we can see some very clear differences in these 2 pans. This one, we've got soil being moved, but in this one, the soil has actually been moved so much that this entire area at the top here has been completely cleaned of sand, and we can see the foil pan underneath. Once again, interestingly, we've got the 2 grooves in the way the water flowed down, but This one, it's much more pronounced. There's a lot of soil on this side that isn't on this side, so it's been pushed down all the way over to the edge of the pan, and if we take those out and look at them, we should be able to see that there's a lot more soil in the second pan. Now you could actually get the kids to pour out the water and then get the soil and put it into a container with volume marks on it, measuring it in millilitres or cubic centimetres, and you can actually measure the amount of material that has been moved completely out of that first pan and into that second pan. And this is really important for what is going to be happening next, which is taking our results and turning them into evidence-based claims.